Determine the draft in terms of the diameter or side of the solid bodies when floated in mercury. So the first, a solid sphere made of steel of specific gravity 7.86. Second, a solid equilateral triangular wedge made of lead specific gravity 10.3 with side x and length L greater than x, and with apex down, letter B, apex up. So for the general expression, weight equals buoyant force, specific gravity of the body times gamma of water times volume of the body equals specific gravity of fluid gamma of water times volume displaced. So we can cancel gamma of water. So volume displaced is specific gravity body over specific gravity of fluid times volume of the body. So that's our working equation. So for a sphere, that's the figure. We call this spherical segment of one base, the volume displaced. And the volume displaced is pi h squared over 3, quantity 3r minus h. That's the formula. So volume displaced is 7.86 over 13.6 times volume of sphere. The volume of sphere in terms of diameter is pi over 6 diameter cube. So we will express the draft in terms of the diameter. That's why I denoted the draft here by h, not by d, in order not to confuse. So pi over 3, h squared, quantity 3 times radius 0.5d minus h, radius is 0.5d, equals 7.86 over 13.6. Volume of sphere is pi over 6 diameter cube. So cancel pi, and we cross 3 here. So 1.5d h squared minus h cube equals, the right side in terms of diameter cube is 393 over 1360 diameter cube. So simplifying, h cube minus 1.5d h squared plus 393 over 1360 d cube equals 0. So there are 3 roots expected there. You'll just imagine d is 1. So that h is in terms of d. So using the calculator, high-tech, or by trial and error, h is negative 0.3909d, 1.339d, and 0.5521d. So among these roots, of course, this is impossible. 1.339d is absurd because it is beyond the diameter. So the value of h is 0.5521d. Then for the second part, this is the orientation. The apex is down first. This is the volume displaced. So volume displaced equals specific gravity of the body, which is 10.3 over specific gravity of fluid 13.6 mercury times the volume total. Then volume displaced is area displaced, area below the mercury surface times length, and volume total is area of the equilateral triangle times L also. So area displaced times length, that's the volume displaced, equals 10.3 over 13.6, then 1/2 x squared sine of 60 degrees times L. Cancelling out L, area displaced is equal to 0.32794 of x squared. Now this area displaced, if I call the dimension as y, this will be y, because this is an equilateral triangle and this is 60 degrees. So the area of equilateral triangle or triangle is 1/2 product of adjacent side sine of the included angle. So area displaced is 1/2 y squared sine of 60. Since cosine of 60 degrees over 2 is d over y, d over hypotenuse y, this is the y. So y is 1.155 of d. Then the area displaced is 1/2 y squared sine 60, 1/2 y 1.155d quantity square sine 60 degrees equals 0.32794x squared. So from here, we can solve for the 0.32794 x squared times 2 divided by quantity 1.155 square sine 60 and extract the square root. So D is 0.7535 of x. Then for that second part, apex is up. That's the figure. I'll call this portion that is exposed as Z. Everything will be Z there. And remember the angle is 30 degrees. So area displaced is still 0.32794 of x squared because this is the same wedge and same area displaced. It's only the orientation that is changed. So this area is area of big equilateral triangle minus area of small equilateral triangle. So area displaced is 0.32794 x squared. Area of big equilateral triangle is 1/2 x squared sine 60. Then area of this exposed equilateral triangle is 1/2 z squared sine of 60. Then equals area of 10.3 over 13.6 area of equilateral triangle. I just repeat this. 1/2 of x squared sine 60. So we can cancel sine 60 over 2. Then we have x squared minus z squared equals 10.3 over 13.6 of x squared. So we can now solve for z in terms of x. Square root of x, square root of quantity 1 minus 10.3 over 13.6. That's the value of z. So 0.4926 of x. From the figure, the height of the equilateral triangle is x cosine 30, that one, because half of 60 is 30, so hypotenuse cosine 30, that's the height. Then z is also hypotenuse of this exposed area, so this is z cosine 30. Therefore, the graph is x cosine 30 minus z cosine 30. X cosine 30 minus z, which is 0.4926x cosine of 30. So the graph is equal to 0.4394 of x.